Hello and welcome to video number 13 in this series. And in this video I'll demonstrate how to apply what we know about multiplying and dividing fractions to multiplying and dividing rational expressions. So in video number 4 in this series we went through some examples of multiplying fractions. For example, 2/3 times 5/7. And we noted that all we do is multiply the numerators and multiply the denominators. So we got 2 times 5 over 3 times 7, which is 10 over 21. So we do something similar if we're multiplying rational expressions. So for example, if I have this rational expression, 2x squared plus 3 divided by minus 3x plus 1, and I want to multiply that rational expression by x minus 4 over x squared plus 2. I'll actually use a dot here to signify multiplication so it doesn't get mixed up with the x's. And so all we do is same thing as we did with fractions. Multiply the numerators and then multiply the denominators. So multiplying the numerators, I'm going to have 2x squared times x. So that's going to be 2x cubed. I'll have 2x squared times minus 4, so minus 8x squared. I have plus 3 times x. And I'll have plus 3 times minus 4. And then in the denominator, I've got minus 3x times x squared, so minus 3x cubed. And then I've got minus 3x times 2, so minus 6x. Plus 1 times x squared, and then plus 1 times 2. Okay, so I've ended up with another rational expression, and in this case we can't simplify this one any further. And just as in the last video, we always need to make sure that our domain is defined when we're dealing with rational expressions, and in particular we can't have the denominator be equal to 0. And so in this case the denominator would be 0 if x was minus 1/3. And actually that's it, because this part x squared plus 2, that is always positive, so that can't be 0. So all we have to do is say for all x not equal to minus 1/3. Dividing rational expressions also works the same as dividing fractions. So if we go back to our first example with the fractions, let's do 2/3 divided by 5/7. So to do this, we leave the first fraction as it is, change the divide to multiply, and again I'll use the dot, and then flip the second fraction. And this is the reciprocal of this fraction. And then apply what we've already done with multiplying fractions. Multiply the numerators, multiply the denominators. So we'll have 14 over 15 in this case. Let's do the same idea using the rational expressions. So let's do 2x squared plus 3 minus 3x plus 1, and let's divide by x minus 4, x squared plus 2. So leave the first rational expression as it is, and then the second one, we turn it upside down. We take the reciprocal. And then we just proceed as we did for the last example. So we'll have in the numerator, let's see, we'll have 2x to the 4, and we'll have a 3x squared and a 4x squared, so 7x squared. And we'll have a plus 6. And in the denominator, we'll have minus 3x squared, and we'll have plus x plus another 12x, so 13x, and we'll have minus 4. And this is defined for all x not equal to, the denominator could be 0 whenever x is equal to minus 1/3 or x is equal to 4. And so let's just work through a couple more examples. And in the next two examples that I'm going to work through, it's always nice if we can simplify our algebra. And so we're going to use the idea of factoring to see if we can simplify the rational expression that we end up with. So let's do this example. Let's do x squared plus x minus 6 for x minus 1 times x squared minus 2x plus 1, and then x squared minus 4. So I'm going to multiply the numerators and multiply the denominators. So I'll have x to the 4 and minus 2x cubed plus 1x cubed, so minus x cubed, and then we'll have minus 2x squared minus 6x squared, so we've got minus 8x squared, and then we'll have minus 6. And then in the denominator we got an x cubed, and we've got a minus x squared, and we've got a minus 4x, and we've got a plus 4. So we've ended up with a rational expression, and it's a little challenging to factor this. It's not impossible because it does actually factor, but let's think a little harder about how to make this a little easier. What if we can factor back here, and then that will lead us to a simpler expression. So in this case, when you're trying to multiply rational expressions or divide them, if you can do any factoring before you start multiplying the rational expressions, the polynomials, you can end up simplifying the final expression you end up with. So let's see if we can do that in this case. So I'm going to kind of forget what I did here and kind of start over. So let's see if we can factor x squared plus x minus 6. Can we factor that quadratic? We need two numbers that multiply to give us minus 6 and add to give us plus 1. So plus 3 minus 2 would work. And then let's see if we can factor this quadratic. So we need two numbers that multiply to give us plus 1, add to give us minus 2. So minus 1 would work there. Minus 1, x minus 1 all squared. And then this is a difference of squares, so I'm going to use conjugates here to factor that. X minus 2, x plus 2. And so now we've got a bunch of factors in the numerator and a bunch of factors in the denominator. So I can do some cancelling here. I can cancel this x minus 2 with this one, and I can cancel one of these x minus 1s with the one down here, and I've ended up with a fairly simple looking rational expression. I've got x plus 3, and I've got x minus 1, and then in the denominator I've got x plus 2. So this answer is much easier to deal with than this one. And so just by thinking ahead and doing some factoring, I ended up with an easier final result. And so we just need to specify the values of x that we're not going to be permitted to use in the domain. And so we just have to look at what values of x would make the denominator 0. So we can have any value of x except for, let's see, plus 1 or plus 2 or minus 2. So x not equal to minus 2 or 1 or 2. Let's do one more example. Let's do a division. Let's do x squared over x squared minus 6x plus 9. Let's divide by 4x over 2x minus 6. And again, let's try and do as much factoring as we can before we start multiplying the polynomials. So I'm going to have x squared, and then see if I can factor this quadratic here. Two numbers that multiply give me plus 9 and add to give me minus 6. So I think minus 3. X minus 3 squared would do that. And then I'm multiplying by, I've got to take the reciprocal of this second rational expression. So I'll have 2x minus 6 in the numerator, so I'll take a factor of 2 there. And then in the denominator I'll have 4x. Okay, and let's see if I can do some cancelling. One of those x minus 3's down here will cancel with this one up here. The x down here will cancel with one of those x's up there. And then the 2 and the 4, I'll have 2 left in the denominator. Now I'm ended up with x in the numerator and 2x minus 3 in the denominator. And this is good for all x not equal to anything that would make the denominator 0. So x equals 3 or x equals 0. Okay, so pause the video at this point and see if you can work with the next two rational expression multiplication or division problems and try to do some factoring before you start multiplying polynomials, and see if you can get to the correct answers. And again, note any values of x in the domain that are not permitted. So for the first example, let's do a multiplication. So let's do x squared minus x minus 6 over x cubed plus 2x squared. Let's multiply that rational expression by x squared plus 2x plus 1 divided by 2x squared minus 4x minus 6. And then the second one, let's do x cubed plus 3x squared plus 3x plus 9 divided by x squared minus 4. And let's divide that by x squared plus 2x minus 3. and x squared plus x minus 2. Okay, so let's see how you did. This first one, let's see if I can factor this quadratic up here. Two numbers that multiply to give me minus 6 and add to give me minus 1. So x minus 3, x plus 2 should work. And then see if I can factor this quadratic as well. Two numbers that multiply to give me plus 1 and add to give me plus 2. So x plus 1 squared. And then let me factor this polynomial here. So I can pull out an x squared. And then I'll have x plus 2. And then see if I can factor this quadratic. Well, if I pull out a 2, then I'll be left with x squared minus 2x minus 3. And two numbers that multiply to give me minus 3 and add to give me minus 2. So I think x minus 3, x plus 1 should work. Let's just check that. X squared minus 3x plus x minus 2x and then minus 3. Yeah, I think that works. Okay, let's do some cancelling. Let's see, I got x minus 3 and x minus 3, x plus 2 and x plus 2, x plus 1 squared and x plus 1, so one of those x plus 1s would cancel on the numerator. And I'm left with x plus 1 in the numerator and 2x squared in the denominator. And this is valid for all x not equal to, there's a few values of x that I'm not permitted to use here. 0, minus 2, plus 3, and minus 1. Let's try and write those in order. We're not allowed minus 2 and minus 1 and 0 and 3. I think I got them all. Okay, so that's the solution for the first problem. And for the second one, let's see. So let me try and factor this cubic expression. If I do x squared and x, so I'm going to have two numbers here that multiply to give me 9, and I'm going to want a 3x and a 3x squared. So I think if I just put plus 3 here and here, I think that should work. So I've got x cubed, I've got 3x squared, I've got 3x, and I've got 9. So that works. And then I'm dividing by this rational expression, so I've got to take the reciprocal. I've got to flip it upside down. So I've got x squared plus x minus 2 in the numerator, and I'm going to factor that if I can find two numbers that multiply to give me minus 2 and add to give me plus 1. So I think x plus 2, x minus 1 would work, because I've got the minus 2, and then I've got plus 2x minus x, so I've got the plus x as well, so that's good. And then in the denominator, I recognize this as a difference of squares, so I'll factor that using conjugates. And then, remember, I flipped the second rational expression upside down, so now the numerator is in the denominator, and I'm going to try and factor that quadratic. Two numbers that multiply to give me minus 3 and add to give me plus 2 would be x plus 3, x minus 1. I think that's right. Let's just check. I got plus 3x minus an x. I got plus 2x, and I got plus 3 times minus 1 is minus 3. Okay, so now I'm going to do my cancelling. Let's see. I got x plus 3. I got x plus 2. I got x minus 1. So this simplifies quite a lot. X squared plus 3 in the numerator and x minus 2 in the denominator. And this is valid for all x not equal to anything that makes the denominator 0. So minus 3 and minus 2 and 1 and 2. So that's it for this video. And in the next video, we'll finish up our exploration of rational expressions by looking at adding and subtracting them.